All right, so I'm just going to run through the tree diagram question on page 417. This is question 11, because it's a bit involved in it and it kind of covers a lot of what we need to know about this stuff. So we've got Aaron and Billy running an 800-meter race followed by a 1500 race, and then based on their prior performances, we've got these probabilities that they'll win. Okay, so it's an 800-meter race. 1 in 5 chance Aaron wins, 2 in 5 chance Billy wins, a 2 in 5 chance neither of them win. And if you add those three probabilities up, they add to 5 over 5, which is 1, because they're all the possible outcomes. Aaron wins, Billy wins, or someone else does. So neither of them win. Okay, so they add to 1. The first thing I'm asked to do in this question is just to complete this table. So they've given me the probabilities for the 1500-meter race for Aaron and for Billy, but not for neither. But as I said, they're all the possible outcomes. So they should add to 1. All right. So the neither you're looking for is the probability that satisfies this equation. So it's the one that makes this left-hand side equal to 1. So what is 1 over 4 plus 1? 1 over 4 plus 1 over 3 is 7 over 12. So 7 over 12 plus something is equal to 1. So look, it's going to be 5 over 12 if you want to do it kind of properly as an algebraic one. Bring the 7 over 12 over, it becomes minus 1 minus 7 over 12 is 12 over 12 minus 7 over 12. So 5 over 12 is the missing probability there. So a 1 in 4 chance Aaron, a 1 in 3 chance Billy, 5 in 12 chance then the field, okay, that neither of them win, that someone else wins. All right. I'm then asked to complete this tree diagram below, and they want me to do the tree diagram, fill out all the outcomes, and fill out all the probabilities as well of each outcome. All right. So I'm not just honing in on one of them like I am in some questions. So you see the third part here is what's the probability that Aaron and Billy won a race each. So I might be able to just kind of focus in on maybe 1 or 2 outcomes. But the way this is asked, I need to fill out all the outcomes, all the probabilities. So first thing that happens is there's an 800-meter race. So that's our kind of first kind of branching point on our tree diagram. And in that 800-meter race, Aaron wins, Billy wins, or neither of them win. Okay, so there's my 3 possible outcomes. Okay, if Aaron wins the 800, what can happen on the 1500? Well, it's the same 3 things that can happen. Aaron can win, Billy can win, or neither of them can win. So here's where the 1500 meter is coming in. If Billy wins the first one, what can happen on the second one? Aaron, Billy, or neither. If neither of them win the first one, what can happen on the second one, the 1500? Same thing. Aaron can win, Billy can win, neither of them. All right. So there's 3 possibilities here, 3 possibilities here for each one. 3 by 3. I should end up with 9 possible outcomes over here. So this is where my outcomes are going to go. So my outcome here is Aaron, Aaron. My outcome here, Aaron, then Billy. So A, B, Aaron, then neither. Billy, then Aaron. Billy, then Billy. Billy, then neither of them. Neither of them, then Aaron. Neither of them, then Billy. Neither of them, then neither of them. All right, so that's all my outcomes there. All right, my probabilities then. So look, I would say fill out the probabilities onto your branches here will make this easier. So on the 800-meter race, what can happen? It's a 1 in 5 chance for Aaron. It's a 2 in 5 chance for Billy, and a 2 in 5 chance for neither. In the 1500 then it was 1 in 4 for Aaron. And that's kind of independent of what happens before. That doesn't change depending on the first race. So it's always going to be 1 in 4 that Aaron wins the 1500. It's always going to be 1 in 3 that Billy wins that race. And it's always going to be, as we figured out here, a 5 in 12 chance that neither of them win it, someone else wins it. Now, what are my probabilities here? For Aaron, it is going to be 1 in 5 multiplied by 1 in 4. So you multiply across these branches, okay? So when you're combining events, Aaron and then Aaron. So you multiply the probability that Aaron wins the first one by the probability he wins the second one. So 1 in 5 multiplied by 1 in 4 is 1 in 20. Aaron then Billy, 1 in 5, then 1 in 3. So 1 in 5 multiplied by 1 in 3, and that is 1 in 15. Aaron, then neither of them, is 1 in 5 by 5 and 12. So 1 in 5 multiplied by 5 in 12, and that will end up being 1 in 12 when you multiply that out. Billy, then Aaron, so that's 2 in 5, then 1 in 4, so it would be 2 in 5 multiplied by 1 in 4. So that would be 2 over 20, that is 1 in 10. Billy, then Billy, so that is 2 in 5 and then 1 in 3, so 2 in 5 multiplied by 1 in 3, that is 2 in 15. Billy, then neither, 2 and 5 by 5 and 12. That would be 1 in 6. All right. Neither, then Aaron, 2 and 5 and then 1 in 4. So 2 in 5 multiplied by 1 in 4. That will be 2 over 20, which is 1 in 10. Neither, then Billy, so 2 and 5 and 1 in 3. So 2 and 5 multiplied by 1 in 3 is 2 over 15. Neither, then neither, 2 and 5 by 5 and 12 would be 1 in 6 again. All right, so there's all your possible outcomes. As I said, I would expect 9 of them because there's 3 different results on the 800, 3 different results on the 1500. So when you combine them, 3 by 3 is 9. So 9 possible outcomes. All right, to get the probability then of each outcome, as I said, you're multiplying along the branches. So just be careful you're putting the correct probabilities on the branches. And then, for example, for Aaron and then Aaron, it is 1 in 5 multiplied by 1 in 4 and ends up 1 in 20. Okay, I can check my answers here because this is all 9 possible outcomes when we run those 2 races. Okay, from our point of view, there's 9 possible outcomes. Aaron, Billy, neither. All right, on 2 different races. So if I add all these together, they should add to 1 because they're all the possible outcomes. Okay, so if you add all the possible outcomes, you should get 1. So 1 in 20 plus 1 in 15 plus 1 in 12 plus 1 in 10 plus 2 in 15 plus 1 in 6 plus 1 in 10 plus 2 in 15 plus 1 in 6. And there it is, 1. All right, so if you add up all the possible outcomes at the end of the decision tree like this, they should add to 1. All right, that's just checking my answer. I'm not asked to do that. What am I asked to do in the part 3 here? What's the probability that Aaron and Billy win a race each? Okay, so a race each I would interpret as Aaron wins 1 and Billy wins 1. So where are the ways that that happens? So Aaron wins 1, Billy wins 1. We've got it there. And we've got it there. And that's the only way it can happen. So here, Billy isn't winning one, Billy isn't winning one, Aaron isn't winning one, Aaron isn't winning one, Billy isn't, Aaron isn't, neither of them are winning. Okay, so there's the only way where they win a race each. Okay, so it's a 1 in 15 chance that this happens. It's a 1 in 10 chance that that happens. Okay, so the probability that it's this or this, you're going to add these probabilities together. Okay, so just doing it up here, it will be 1 in 15 plus 1 in 10. Which is a 1 in 6 chance. Okay, so it's a 1 in 6 chance that we get a race each. So that's the probability of winning a race each. The reason I add them together is because these two things can't happen. Okay, you can't have a situation where Aaron wins the first one, then Billy wins the second one, and Billy wins the first one and Aaron wins the second one. These are kind of two distinct possible outcomes. So either this thing happens or this thing happens. Okay, when you've got or events and probability this or this, you are adding the probabilities together. So I add them together and I get a 1 in 6 chance. All right, so a couple of things to be careful of. Those or meaning adding them together, and just be careful of the wording here of the question. Okay, just as I said, read those carefully and kind of hone in just on the outcomes that they want.